Right, welcome back. So this is the final installment in my short series of videos on GPSs at speed. If you remember, I've been looking at small GPSs that'll fit on the back of a copter, and I've got an M10 micro here that I've been fitting to a lot of my copters. And I've compared the Maytech M10Q with a compass on it with the Haribo M10 Micro M9N Micro, and finally we've got the F9P, which as a reminder looks like this. So a little bit bigger than the other ones. You kind of see it, a little bit bigger. But does just about fit on the back of a copter, and thanks to my friend Justin, nice little TPU mount there. So I guess the difference with this one is that it's got a helical antenna rather than patch antenna like these. So the question is, and these, because it's F9P, it can do RTK. I wasn't testing RTK, so really I'm just testing the basic GPS properties, but it is a lot more expensive. So these are about $300, I want to say. The others are about $50. So a lot more expensive. You're mainly paying for the RTK support, but interesting to see whether the regular GPS support is any better. So if you watched any of the other videos, you'll know the score. So so this is running at 5 hertz. And so, one of the first things, well, first of all, we can see what did we get up to speed-wise. So, a little map here. Interesting. Don't know why the map has zoomed out. Huh. Feels like Mission Planner isn't playing ball here. All right, so we'll do it without the map. So let's have a look. I did update Mission Planner today, so maybe something has changed. All right, so IMU, where we see we've got 2 flights here. That says old hold, which is not correct. That feels like a wrong graph. Okay, so let's pause this and find the right graph. All right, we're back. So what I forgot was I did actually have to calibrate the compass, so that was my compass calibration test in all hold doing figure of eights. So here we got the right graph, and this time we can see a bunch of high throttle output, and the map is playing ball this time, so I don't know quite why it wasn't before. So you can see again doing a sort of box pattern with sort of nice S-curves. And let's have a look at what the IMUs got up to. So if you remember, okay, so we've got 2 IMUs, and it's the ZXL, so the interesting ones. So you can see here I reached full throttle here, and the Excel's got to 6.5 Gs. So not quite as high as some of the other, but still pretty good. Yeah, so what did the GPS get up to? So the first thing to do is, just have a look at the degree of precision here. So you can see the degree of precision is pretty low. That's really pretty good. So it's whatever that is, 0.50 or something like that. No, 0.58 maybe. So pretty good degree of precision. And just if we compare with the other one, GPS, I think we're GPS 1, degree of precision similar, and then jumps up to sort of 2.5 in the middle here, which is quite high. Just want to just check that that is, no, wrong GPS, that must be the Maytech. So this is the GPS here. So this starts off lower. So okay, it starts off lower than the F9P. So this is the M10, and then jumps up to 0.68 or something. Obviously different days, so could be different satellite coverage, but sort of you get the idea. But still, pretty good numbers. And number of sats is insane. 27 sats dropping to 23 during some of these maneuvers. So you can clearly see the effect of the maneuvers and the speed on the sat count that is able to pick up. And that may simply be because it not facing the sky anymore. And again, interesting to compare with the M10. Have a look at the sat count on the M10. Is here. So this is 23 dropping to 15. So actually doing pretty well, better than the M10. So 27 dropping to 23, which is pretty good. Again, the different day may have something to do with it, but still that's pretty significant. And then the other thing I always like to look at is on GPA, look at the delta just to see that we're getting nice smooth 5 Hz update, which we are. See that? So then the question is, what do the accuracies look like and what is the EKF make of it? So we've got the accuracy numbers here. So you've got horizontal accuracy, which was down at horizontal position accuracy, down to sort of half a meter, just over half a meter, rising to just over 1 meter, 10 centimeters. So pretty good. Vertical position accuracy, a little bit worse, so 0.8 rising to about 1.5 meters. And then the speed accuracy, so is really pretty good. So I think this will be in meters per second. So this is down at 0.1, rising to 1 meter a second accuracy. And then your accuracy I'm not so interested in. So interesting to compare these with the M10. So if we switch back to the M10 here, so this is the M10, and if we have a look, just stick up the throttle again so you can kind of see that. M10 GPA accuracy, so vertical accuracy higher, so it's, well, 0.5 rising to 1.3, a little bit worse. Oh, sorry, it's vertical degree of precision. No, we want this one. Horizontal accuracy. Okay, so 0.5 rising to 1.5, so a bit worse. Vertical accuracy 0.6 rising to 1.6, so similar-ish, maybe a little bit worse. And then speed accuracy 0.1 rising to 1.2. So going back to here, so you've got 0.1 rising. So similar. Clearly the F9P is a bit better, maybe 10% better with these things, but it's not huge. It's not like the difference between the M10Q and the M10 Micro, for instance. And then if we have a look at the EKF, it's XKF. So we've got SV, SP, SH, SM. Okay, so just drill in this a little bit. So you can see that the worst one is the magnetic field variance, and that's kind of expected, nothing to do with GPS. So that's kind of expected because obviously a lot of current flowing through. Let's just get these events out of the way. So the orange line here is height accuracy, and you can see that goes up to 2 meters. It goes from, sorry, height innovation. So you want these innovations to be less than 1. So interesting. So the height innovation goes up to 1.5. So that's pretty bad. That may be because we're using, I can't remember whether you're using the barrow or the GPS for height here. That may be because we're using the barrow. That would explain things. You can probably tell from the parameters. Have a quick look at the parameters. What does, you can't see this, but what does EK3 source pos Z? No, EK3 source 1 pos Z says it's using the GPS, so that's not great. So the height accuracy 1.9, 1.8 is pretty bad. Position accuracy is this blue line, which is at least stays below 1, so rising to 0.6 maybe. And then the green one is the velocity accuracy, and that again gets up above 1, so that's not great. So it's anything above 1 is bad, and the EKF is in all sorts of trouble. And if we sort of go back to the M10, which is this one, yeah, that's the right graph. So we'll get rid of all these GPA things. Go to the, I honestly can't remember what this was like. I feel like it was a little bit better. So if we go to the velocity accuracy, position accuracy, height accuracy, so those are substantially better. So position accuracy, again, let's get rid of these errors and events so you can see. So the green one is the worst. That's the velocity innovation. That gets up to 0.75. So high, but it's still below 1. The blue line is the position accuracy, position variance, and that gets up to 0.45, so pretty good really. And then the orange one is the height accuracy, is 0.35, so really pretty good. So on the, as far as the EKF is concerned, the M10 micro is much better. And I must admit I'm struggling to explain that a little bit because the actual GPS results look similar. So I'd have to dig into a bit why. I'm not sure these are replay logs, but I have to figure out why the innovations for the F9, which is here, why are those innovations so bad? I'll just replot those again just in case we've done something wrong here. No, velocity well above 1, position is okay, and then height is way out, and it's using, so really this GPS, the EKF was struggling with this GPS, and let's just check I've got the right GPS. I might be looking at the wrong GPS. Let's just have a look at these. P. Oh, looking at the wrong GPS. There we go. That's why. So that was the M10Q. No, it can't be the M10Q. I don't have 2 GPSs on this. Interesting. this can't be the right log. Can't be the right log. There's not 2 GPSs mounted. All right, I have to stop that. All right, back again. So after a little analysis, I'm pretty sure one of those GPSs was the F9P, because I don't think I would have got the number of sats and other things seem consistent. So I'm not quite sure how I had 2 GPSs going at the same time. So maybe in the log messages I can only see 1 GPS recognized. So maybe it's I just can't explain it. Anyway, here's the next log, which taken on the same day. It's still high throttle. If we look at a map, we're doing a box pattern. And this time we've only got 1 GPS. You can see that here. Number of sats, 28, falling to 25. So I definitely think this is the F9P. H dot 0.5 something rising to 0.65. So this is definitely the F9P, high throttle. So let's go back and just look at all of this data again. So and hopefully it'll show a similar pattern to the data we've just looked at. So horizontal, vertical, speed accuracy. And so we've got same sort of pattern. Speed accuracy is nice and low down here, nearly 0.1 meters a second, rising to 1 meter a second. Green one is horizontal accuracy 0.5, rising to 1 meter. Blue vertical accuracy 0.7, rising to 1.6 meters. So a little bit worse than the, well, no, similar, I guess, to the M10, which is, this is the M10. So if we clear this graph, just remind ourselves, there's the throttle, horizontal, vertical, speed. That seems good. So, okay, so these are a bit worse, you can see. So vertical accuracy going up to 2.2 meters. Speed similar to start with, rising a bit higher. So yeah, not quite as good. So this, from this perspective, the F9P looks better. And quick check that delta is still good, and it is. Okay, delta is still good. All right, so if we then switch to the EKF, take out these, what did the EKF make of this? So back to XKF4, and we've got vertical, position, horizontal. And so the picture is similar. So height is not as bad as the other one was, 0.4. If you remember, the height was really quite bad in the other one. Position is the blue one, so it's about 0.55. And velocity variance gets up to 1, just about. So that's not great. And if we look at previous log here from the M10, just to remind ourselves, so back here again, so height is, you know, lower, velocity a bit lower, 0.7, position a bit lower, 0.45. So really, as far as the EKF is concerned, the F9P is a bit worse. Not a huge amount, but a bit worse, a bit more accurate, but a bit worse. It could be that we're going a bit faster. We should just check that, I suppose. So if we have a look at these, so it'll have a bit more acceleration. Let's have a look at what the IMUs thought about this run. So IMU Z, there's the Z axis. The F9P gets to 0.68 Gs, at the most. And in the M10, switch back again. Get rid of these. The IMUs think in the Z-axis. Get to 0.75, so higher. So, or very similar. So really, these are very similar runs, very similar profiles. And although the GPS claims more accuracy, the EKF is not very happy about it. Not as happy about it, I should say. And so, let's just go back to the F9P here. So, you know, within the bounds of experimentation, you would say that these two are pretty much alike, pretty much similar in performance. But of course, this is 6 times expensive. So if you don't need RTK, and of course RTK, it'd be interesting to do these with RTK. I'm not set up for RTK on this copter, but I probably should do something about that. That'd be quite cool to set that up. As far as sort of flying small copters around quickly, I would say the M10 Micro is my pick. So that just seems to be the best bang for the buck, and works really well in all the experiments I've done. And I have to say, it works so well that I've installed 4 of them on some of my small copters. So yeah, I think my summary would be all of these sort of slightly higher priced, bigger GPSs are definitely better, significantly better than these very, very small GPSs. But my sort of top pick is the Holy Bro M10 Micro. So thanks for watching.